Atlantic Ocean, November 17, 1944. Kapitän Lieutenant Heinrich Weber pressed his eye against the periscope lens, watching the impossible unfold before him. Through the gray Atlantic swells, an endless convoy of American Liberty ships stretched toward the horizon, each one burning precious fuel as if it were water itself. His weathered hands trembled slightly as he adjusted the focus. For 3 years, his U-boat had stalked these very shipping lanes, sending countless tankers to the ocean floor. The Reich's strategy was simple: strangle America's fuel supply, force their war machine to grind to a halt. Yet here they were, more ships than ever, their engines humming with abundant power, their escorts racing through the waves without a care for conservation. Weber lowered the periscope and turned to his chief engineer. "Mein Gott," he whispered, "where does it all come from? We've sunk their tankers, we've cut their supply lines. They should be running on fumes by now." What Weber couldn't know was that thousands of miles away, in laboratories and industrial plants across America, scientists had achieved what German admirals would later call pure magic. They had learned to pull fuel from the endless sea itself. The year 1940 had brought America face to face with a terrifying reality. As German U-boats prowled the Atlantic like hungry wolves, they systematically destroyed the lifeline that kept American industry alive. Every month, dozens of oil tankers disappeared beneath the dark waters, taking with them millions of gallons of precious fuel. The statistics were staggering and frightening. In 1942 alone, German submarines sank over 600 merchant vessels along the American coast, creating what military planners called the torpedo alley of death. President Roosevelt stared at the reports flooding into the White House Situation Room. The numbers told a story of impending disaster. American oil reserves were being depleted faster than they could be replenished. Gasoline rationing had already begun on the home front, with families receiving small stickers for their windshields that determined how much fuel they could purchase. The A sticker allowed just 4 gallons per week, barely enough for essential travel. But the civilian shortage was nothing compared to the military crisis brewing. American destroyers sat idle in harbors because there wasn't enough fuel oil to power their massive engines. Bomber squadrons grounded their planes to conserve aviation gasoline. Tank divisions reduced training exercises to preserve diesel. The most powerful military machine in the world was slowly grinding to a halt, not from enemy bullets, but from empty fuel tanks. Admiral Ernest King, Chief of Naval Operations, delivered the sobering truth to his staff officers in a closed-door meeting that December. "Gentlemen," he said, his voice heavy with concern, "if we cannot solve this fuel crisis within 18 months, we will lose this war, not to German guns or Japanese bombs, but to empty gas tanks." The German strategy was working perfectly. Admiral Karl Dönitz had calculated that sinking 700,000 tons of Allied shipping per month would force America and Britain to surrender within 2 years. His U-boat commanders were exceeding those targets with ruthless efficiency. Every torpedo that found its mark brought Germany closer to victory through economic strangulation. In Texas oil fields, workers pushed aging wells beyond their limits, but domestic production couldn't match the losses at sea. The great oil fields of the Middle East remained largely untapped, and getting that oil across submarine-infested waters seemed impossible. American petroleum engineers watched their strategic reserves dwindle with each passing month, knowing that winter would bring even greater demands for heating oil. The crisis extended far beyond military needs. American factories that produced everything from ammunition to aircraft required enormous amounts of fuel oil to power their machinery. Steel mills needed coal and oil to keep their furnaces burning at the temperatures required to forge the weapons of war. Chemical plants that manufactured explosives and synthetic rubber depended on petroleum-based feedstocks that were becoming increasingly scarce. In the darkest hour of America's fuel crisis, a quiet revolution was beginning in the laboratories of brilliant scientists who refused to accept defeat. Dr. Ralph Landau stood before a blackboard covered in complex chemical equations at the Massachusetts Institute of Technology, explaining to a small group of researchers how German scientists had already unlocked one of chemistry's greatest secrets decades earlier. The Fischer-Tropsch process, developed by German chemists Franz Fischer and Hans Tropsch in the 1920s, could transform simple carbon monoxide and hydrogen into liquid hydrocarbons, essentially creating synthetic gasoline and diesel fuel from basic chemical building blocks. Germany had been using this technology since the mid-1930s to reduce their dependence on imported oil, building massive synthetic fuel plants that powered their war machine. But American scientists saw possibilities that even the Germans had missed. If you could create fuel from carbon monoxide and hydrogen, and if you could extract those gases from seawater through electrolysis and other chemical processes, then the ocean itself could become an unlimited fuel depot. The concept was so audacious that many established petroleum engineers dismissed it as fantasy. Dr. Eugene Houdry, a French-American chemical engineer who had already revolutionized petroleum refining, assembled a team of the nation's brightest minds at his research facility in Pennsylvania. Working 18-hour days, they modified the Fischer-Tropsch process for American conditions and materials. The breakthrough came when they discovered that certain catalysts could dramatically increase the efficiency of the synthesis reaction, making large-scale production economically viable. The first experimental plant was built in secrecy at a remote location in Louisiana during the summer of 1942. Local residents were told it was a new type of chemical factory, which was technically true. The initial results were promising but modest, just a few barrels of synthetic fuel per day. However, the quality was exceptional. When tested in military vehicles, the artificial gasoline performed identically to petroleum-based fuel. Word of the project reached the highest levels of government through classified channels. Secretary of War Henry Stimson personally visited the Louisiana facility in September 1942, watching in amazement as technicians filled a Jeep's gas tank with fuel that had been created from seawater just hours earlier. The Jeep started immediately and ran smoothly, its engine producing no unusual sounds or emissions. The implications were staggering. If this technology could be scaled up to industrial levels, America would become energy independent overnight. More importantly, the German U-boat campaign would become irrelevant. You can't sink seawater with torpedoes, and America was surrounded by 3 massive oceans containing enough raw materials to fuel the war effort for centuries. President Roosevelt authorized unlimited funding for the project in October 1942, signing a classified executive order that would remain secret for decades. The Manhattan Project was developing atomic weapons, but this synthetic fuel initiative might prove equally crucial to winning the war. Scientists and engineers were recruited from universities and oil companies. East across the nation sworn to secrecy and transported to new facilities being constructed at breakneck speed. The human story behind America's synthetic fuel revolution began with ordinary people doing extraordinary things under incredible pressure. Dr. Sarah Martinez had been teaching organic chemistry at a small college in Ohio when military recruiters arrived at her door in January 1943. They offered her a position at a classified government facility working on important war research. She packed her belongings and traveled to a fenced compound in the desert of New Mexico, where she discovered that her expertise in molecular synthesis would help win the war. Working alongside Martinez were dozens of other scientists who had abandoned comfortable academic careers to chase an impossible dream. Dr. Robert Chen, a chemical engineer from California, spent his days analyzing catalyst compositions, searching for the perfect combination of metals and compounds that would convert seawater into aviation gasoline. His laboratory notes, still classified decades later, show the painstaking trial and error process that gradually improved the efficiency of the synthesis reaction. The human cost of this research was enormous. Scientists worked 7 days a week, sleeping in barracks adjacent to their laboratories. Many suffered from chronic fatigue and stress-related illnesses. Dr. Martinez later recalled the pressure they felt, knowing that every day of delay meant more American ships sinking in the Atlantic. "We weren't just creating fuel," she said in a 1980s interview. "We were racing against time to save American lives." From a technological perspective, the challenge seemed almost insurmountable. Converting seawater into usable fuel required multiple complex chemical processes operating in perfect coordination. First, electrolysis units separated water into hydrogen and oxygen. Then, specialized reactors extracted carbon dioxide from seawater and converted it into carbon monoxide. Finally, The Fischer-Tropsch synthesis combined these gases into liquid hydrocarbons using carefully designed catalysts operating at precise temperatures and pressures. The strategic implications were revolutionary. Traditional warfare had always been limited by logistics. Armies could only advance as far as their supply lines could support them. But if military forces could create their own fuel from seawater, they would gain unprecedented operational flexibility. Naval task forces could remain at sea indefinitely without returning to port for refueling. Bomber squadrons could operate from remote islands without requiring massive fuel shipments. German intelligence officers had begun noticing unusual patterns in American military operations by early 1943. U-boat commanders reported that American convoy escorts seemed less concerned about fuel conservation than in previous years. Luftwaffe pilots observed American bombers making longer flights without apparent concern for fuel efficiency. These subtle changes suggested that America had solved its fuel crisis, but German analysts couldn't understand how. The moral dimension of the synthetic fuel project weighed heavily on the scientists involved. They knew that their work would enable American forces to strike deeper into enemy territory, potentially ending the war sooner, but also increasing the destructive power of military operations. Dr. Chen wrote in his personal diary that he struggled with the knowledge that the fuel he was creating would power bombers that would kill thousands of enemy soldiers and civilians. Industrial transformation accelerated as the technology proved successful. American chemical companies retooled their facilities to produce synthetic fuel components. Oil refineries modified their equipment to process artificial petroleum. The entire energy infrastructure of the nation began shifting toward this new technology, creating jobs for thousands of workers and generating unprecedented industrial capacity. The German perspective on America's fuel situation revealed a mixture of confusion, denial, and growing alarm as 1943 progressed into 1944. Admiral Donitz reviewed U-boat patrol reports in his headquarters bunker, searching for explanations that continued to elude him. His submarine commanders were sinking more American tankers than ever before, yet American military operations showed no signs of fuel shortages. If anything, American forces seemed to be operating with greater frequency and intensity. Oberst Hans Muller, a German intelligence analyst stationed in neutral Switzerland, compiled reports from agents across Europe who were monitoring American industrial activity. The intelligence was baffling and contradictory. American oil refineries appeared to be operating at reduced capacity, suggesting fuel shortages. However, American military bases showed increased activity levels that would be impossible without abundant fuel supplies. Muller's reports to Berlin grew increasingly frustrated as he tried to reconcile these contradictions. The economic warfare implications were staggering. Germany had invested enormous resources in submarine construction and deployment, believing that cutting off America's fuel supply would force a negotiated peace. If America had indeed achieved fuel independence through some unknown technology, then Germany's entire naval strategy would become obsolete overnight. Worse yet, the resources devoted to U-boat construction could have been used for other military purposes. From the perspective of German military leaders, the situation bordered on the supernatural. General Wilhelm Keitel, chief of the German Armed Forces High Command, received briefings that painted an impossible picture. American bomber formations were conducting raids deeper into German territory with apparent disregard for fuel consumption. American tank divisions were advancing across Europe without the usual logistical constraints that limited armored operations. American naval forces maintained extended patrols that should have been impossible given their supposed fuel shortages. The industrial espionage efforts intensified as German agents desperately sought answers. Spies infiltrated American chemical companies looking for evidence of new refining techniques. German scientists analyzed captured American fuel samples, searching for unusual chemical signatures that might reveal new production methods. Every test showed conventional petroleum products, providing no clues about their mysterious origin. The psychological impact on German leadership was profound. Hitler had built his war strategy around the assumption that America's industrial might could be neutralized by cutting off raw material supplies. If America could create unlimited fuel from seawater, then other raw materials might be synthesized as well. The economic foundation of German war planning was crumbling, even though German leaders didn't fully understand what was happening. German propaganda ministers faced an impossible task. How could they explain to the German people that their U-boat heroes were winning battle after battle, sinking American ships with devastating efficiency, yet somehow failing to achieve strategic victory? The heroic narratives of submarine warfare began to sound hollow as American resistance strengthened rather than weakened. The technological race took on desperate urgency. German scientists, already stretched thin by multiple weapons development programs, were ordered to investigate synthetic fuel production. However, Germany lacked the industrial capacity to build large-scale synthetic fuel plants while simultaneously fighting a multi-front war. Resources that might have been devoted to advanced weapons research were diverted to understanding American energy independence. Intelligence failures compounded the problem. German agents in America reported seeing nothing unusual at petroleum facilities because the synthetic fuel plants were hidden in remote locations and disguised as conventional chemical factories. The compartmentalized nature of the American program meant that even workers at these facilities often didn't understand the full scope of what they were producing. The moment of full realization came in March 1944, when German naval intelligence finally pieced together the impossible truth. Kapitän zur See Wolfgang Heide, chief analyst for U-boat operations, sat in his cramped office in the Kriegsmarine headquarters, staring at a map covered with red pins marking successful torpedo attacks. Over 1,200 Allied vessels had been sunk in the past 18 months, yet American fuel supplies seemed more abundant than ever. The breakthrough in understanding came from an unexpected source. A German chemist named Dr. Klaus Weber, working at a captured French research facility, had been analyzing fuel samples taken from downed American aircraft. Using sophisticated spectroscopic analysis techniques, he discovered something extraordinary. The fuel contained isotopic signatures that were impossible in naturally occurring petroleum. The carbon-to-hydrogen ratios were too perfect, too uniform. This fuel had been manufactured, not refined from crude oil. Dr. Weber's report reached Berlin on March 15, 1944, sending shockwaves through the German high command. The implications were terrifying and immediate. America had not only solved their fuel crisis but had done so using technology that Germany barely understood. The entire foundation of German naval strategy, economic warfare through submarine attack, had become obsolete. Admiral Dönitz called an emergency meeting of his senior staff officers. The faces around the conference table reflected a mixture of disbelief and growing panic. "Meine Herren," Dönitz began, his voice tight with controlled emotion, "we are no longer fighting a war of resources. We are fighting a war against American industrial magic." The German response was swift and desperate. Every available intelligence asset was redirected toward uncovering the secrets of American synthetic fuel production. Agents were ordered to infiltrate American chemical facilities at enormous personal risk. German scientists were pulled from other projects and assigned to reverse engineer the American process based on limited fuel samples and theoretical calculations. Meanwhile, American production was reaching industrial scale. The synthetic fuel plants that had produced just barrels per day in 1942 were now generating thousands of gallons daily. Multiple facilities operated across the continental United States, each one hidden behind layers of security and misdirection. Workers were transported to these plants in unmarked buses, sworn to secrecy, and monitored constantly by federal agents. The strategic impact was immediate and decisive. American naval task forces that had been rationing fuel oil suddenly found themselves with unlimited range. The Pacific Fleet, previously constrained by fuel logistics, launched a series of island-hopping campaigns that would have been impossible without abundant synthetic fuel. Admiral Chester Nimitz, reviewing operational plans in his Pearl Harbor headquarters, authorized missions that had been deemed too fuel-intensive just months earlier. In Europe, American bomber formations began conducting round-the-clock operations against German industrial targets. The 8th Air Force, previously limited by fuel availability, was now sending massive formations deep into German territory on a daily basis. German air defenses, already stretched thin, found themselves overwhelmed by the sheer volume of American air attacks enabled by unlimited fuel supplies. The moment that would later be remembered as the magic revelation occurred during a high-level German military conference in April 1944. General Alfred Jodl was presenting intelligence reports about American industrial capacity when he paused, looked around the room, and spoke the words that would become legendary. "Gentlemen, what we are witnessing is not superior American engineering. This is magic. They are creating fuel from the sea itself." The full scope of American synthetic fuel production became apparent to German intelligence in the summer of 1944, when intercepted communications revealed the existence of dozens of production facilities operating across the United States. Each plant was producing fuel at industrial scales that defied everything German analysts thought they knew about American petroleum capacity. Oberst Muller, the German intelligence officer who had been tracking American fuel production, finally compiled a comprehensive report that painted a complete picture of the American achievement. His classified briefing to the German High Command on July 20, 1944, detailed how American scientists had not only mastered synthetic fuel production, but had scaled it to levels that made America completely energy independent. The psychological impact on German leadership was devastating. Hitler, already struggling with setbacks on multiple fronts, received news that America could produce unlimited fuel from seawater. His reaction, as recorded by several witnesses, was a mixture of rage and disbelief. "How is this possible?" he demanded. "Our own chemists told us such production was decades away from commercial viability." German attempts to replicate the American process proved futile. Even with captured fuel samples and theoretical knowledge of the Fischer-Tropsch process, German scientists lacked the industrial infrastructure and specialized materials needed for large-scale production. The synthetic fuel plants required enormous amounts of electricity, precision-manufactured catalysts, and complex control systems that Germany couldn't produce while fighting a multi-front war. The strategic situation had reversed completely. American forces, once constrained by fuel logistics, now operated with unprecedented freedom. In the Pacific, Admiral William Bull Halsey's Third Fleet conducted extended operations that kept Japanese forces off balance and unable to predict American movements. The fuel independence meant that American naval task forces could remain at sea for months without returning to port, maintaining constant pressure on Japanese positions. European operations transformed even more dramatically. General George Patton's Third Army, previously careful about fuel consumption during their advance across France, suddenly received orders to maintain maximum offensive pressure regardless of fuel usage. Patton's tanks rolled across the French countryside at unprecedented speeds, their engines consuming synthetic fuel that had been created from Atlantic seawater just weeks earlier. German defensive planning became impossible as American forces operated without apparent logistical constraints. Traditional military doctrine assumed that advancing armies would eventually outrun their supply lines and be forced to pause for resupply. But American forces continued advancing, their fuel tanks somehow always full, their aircraft conducting round-the-clock operations without regard for conservation. The moment of ultimate German recognition came in August 1944, when Admiral Dönitz submitted his final assessment to the German Naval High Command. His report, later captured by Allied forces, contained the phrase that would define German reaction to American synthetic fuel technology. "The enemy has achieved what can only be described as industrial magic. They have made the ocean itself into their fuel depot." German U-boat operations continued through 1944, but their strategic purpose had evaporated. Sinking American tankers could no longer affect American fuel supplies because America was no longer dependent on transported petroleum. The submarine campaign that had once threatened to strangle American industry had become an expensive and ultimately pointless exercise in destruction without strategic value. The broader implications extended far beyond military operations. German economic planners realized that post-war competition with America would be impossible if American industry could operate with unlimited cheap fuel. While Germany remained dependent on expensive imported petroleum, the synthetic fuel technology represented not just a military advantage, but a fundamental shift in global economic power that would persist long after the war ended. The immediate consequences of America's synthetic fuel breakthrough rippled across every theater of World War II, with devastating effect on German strategy. By September 1944, U-boat commanders were filing reports that reflected the complete failure of their economic warfare mission. Kapitän Heinrich Weber, the same officer who had questioned American fuel abundance in November, submitted his final patrol report with bitter resignation. The enemy operates as if fuel costs nothing. Our mission has become meaningless. German naval losses accelerated as American anti-submarine forces, no longer constrained by fuel conservation, maintained constant patrols across the Atlantic. American destroyer escorts and aircraft carriers could afford to pursue U-boats relentlessly, burning enormous quantities of fuel in extended hunts that would have been impossible just 2 years earlier. The hunter-prey relationship had reversed completely. The industrial statistics told the story of transformation. American synthetic fuel production reached 2.5 million gallons per day by late 1944, equivalent to the output of a major oil refinery. This production came from facilities that required no crude oil imports, no vulnerable tanker convoys, and no concern about enemy submarine attacks. America had achieved complete energy independence through technology that German scientists still couldn't replicate. German attempts to target American synthetic fuel facilities proved equally futile. The plants were scattered across the continental United States, far beyond the range of German bombers. Even if German forces could have reached these facilities, their disguised nature made them difficult to identify from aerial reconnaissance. Many were built underground or designed to look like conventional chemical plants from above. The strategic initiative shifted decisively to American forces across all theaters. In the Pacific, Admiral Nimitz launched the most ambitious naval campaign in history, knowing that his task forces could operate without fuel constraints. The island-hopping strategy that would culminate in the assault on Japan became possible only because American warships could burn synthetic fuel without regard for conservation or resupply schedules. European operations accelerated beyond German ability to respond. American bomber formations, previously limited to carefully planned missions that balanced target value against fuel costs, began conducting continuous operations that overwhelmed German air defenses. The combined bomber offensive reached unprecedented intensity as American aircraft burned synthetic fuel in round-the-clock attacks on German industrial targets. The long-term consequences of American synthetic fuel technology extended far beyond immediate military applications, fundamentally altering the global balance of power for decades to come. Post-war economic planning documents, declassified in the 1970s, revealed that American policymakers understood they had achieved a revolutionary advantage that would shape international relations long after the shooting stopped. German industrial recovery after the war was severely hampered by America's energy independence. Traditional German exports of chemical products and precision machinery faced competition from American companies that could operate with dramatically lower energy costs. The synthetic fuel technology, gradually declassified and commercialized, gave American industry a competitive advantage that persisted through the 1950s and beyond. The psychological impact on German military thinking was profound and lasting. Post-war interviews with captured German officers revealed a sense of technological inferiority that had not existed earlier in the conflict. General Wilhelm Keitel, during his war crimes trial, testified that German military planning had been fundamentally undermined by American technological achievements that seemed beyond the realm of normal industrial capability. Soviet intelligence services, allies of America during the war, but competitors afterwards, devoted enormous resources to understanding and replicating American synthetic fuel technology. Captured German documents and interrogated scientists provided some insights, but the full scope of American achievement remained partially secret for decades. This technological gap contributed to Soviet concerns about American industrial superiority during the early Cold War period. The commercial applications transformed American industry throughout the post-war era. Chemical companies that had participated in the classified synthetic fuel program found themselves with advanced catalytic processes that could be adapted for peacetime production. The petrochemical industry exploded as companies applied wartime research to create new plastics, synthetic materials, and chemical products that dominated global markets. International energy markets never fully recovered their pre-war structure. America's demonstrated ability to create fuel from seawater, even if not economically competitive with cheap petroleum in peacetime, represented a strategic reserve that could be activated during future crises. This capability influenced American foreign policy for decades, reducing concerns about oil embargoes and supply disruptions that constrained other industrial nations. The environmental implications, not fully understood at the time, would prove significant in later decades. Synthetic fuel production required enormous amounts of electricity, leading to accelerated development of American power generation capacity. The industrial infrastructure created for wartime fuel synthesis became the foundation for post-war chemical and energy industries that would shape American economic development for generations. The story of American synthetic fuel technology during World War II represents more than just another wartime innovation. It embodies the triumph of human ingenuity over seemingly impossible circumstances. When German U-boats threatened to strangle American industry by cutting off petroleum supplies, American scientists refused to accept defeat. Instead, they achieved what German admirals could only describe as magic, the conversion of seawater into the fuel that powered victory. The broader lesson extends beyond chemistry and engineering to the nature of human problem-solving under extreme pressure. The scientists who worked 18-hour days in remote laboratories, the engineers who scaled up experimental processes to industrial levels, and the workers who operated secret facilities without fully understanding their purpose, all contributed to a technological breakthrough that changed the course of history. Perhaps most significantly, this achievement demonstrated that traditiones, all limitations on human activity, could be overcome through scientific innovation and industrial determination. The ancient constraint of fuel scarcity, which had limited armies and navies throughout history, was eliminated by American ingenuity. The implications reached far beyond military operations to transform peacetime industry and international relations. The German recognition of American synthetic fuel as magic reflected not superstition, but a professional military assessment that America had achieved the impossible. In doing so, American scientists and engineers proved that the impossible is often simply the not yet accomplished, waiting for the right combination of knowledge, determination, and desperate necessity to bring it into reality.